Hey everyone, welcome to this session on build versus buy. Pretty excited to be speaking at this open source data summit alongside some very impressive speakers, and great to have all of you all join this session and listen in. My name is Nishith Agarwal, and today we'll be talking about ways to answer that universal question for your data platform. Should you build it or buy it? Or in other words, should you use open source technologies or managed ones? So a little bit of background about me. Currently, I serve as the director of data at Lyra, where my team builds the data platform, ML platforms and services, and other data products. Before that, I was heading Uber's big data storage and compute team, which managed one of the largest data lake and compute lakes on the planet. I also co-created Apache Hudi back there in 2016. And overall, I've spent about more than a decade building infrastructure. I love to learn. My interests are learning about distributed systems, machine learning, building teams, and blogging. So I think to understand, why build versus buy is important, it's helpful to take a look at the evolution and history of the data platform. A couple of decades ago, on-prem data warehouses dominated the industry. Organizations typically bought licenses for solutions such as Teradata, Vertica, and the emphasis on analytics was low. And almost all of the data tooling was built into this single data warehouse. Slowly, due to large-scale data collection at companies such as Yahoo, Hadoop emerged as a system of choice. Most companies deployed open source versions of this software to build their data lake. And during this era, many of the infrastructure was either built in-house or built using open source software. For small to medium-sized data volumes, on-prem data warehouses continued to provide value. Then came the rise of the cloud and the modern data stack. Snowflake, Redshift, and other cloud data warehouses became a popular choice for many organizations. Rise of the modern data stack provided vendor solutions in different parts of the data stack. S3 became a popular cloud solution, an alternative to Hadoop. Still, large data volumes or volume organizations continue to rely on Hadoop. Now, fast forward to today, Snowflake, Redshift, and other cloud data warehouses still continue to be a popular choice. But a new architecture has emerged, the Lakehouse, that provides the best of both worlds, scale of the Hadoop data lake and the primitives of the data warehouse. So along with many open source technologies, this has paved the way for managed OSS solutions. So what's the takeaway, from our history lesson? There's always been a build versus buy question in the recent decade. This is simply now more important than ever due to the proliferation of tools in the market, emphasis and importance of analytics, good data practices, and tons of new open source software for different data use cases. Mm-hmm. So let's take a quick look at a version of the data stack. Different companies, different people stitch together the data stack in different ways, but more or less falls in many, one or few of these kind of categories. It starts at the very bottom with storage and compute for data management. Next we have the technology to run ingestion pipelines and orchestrate them. Once this raw data is landed, we want to run transformations and generate our data models, the silver and gold layers in the medallion architecture. And then finally, we need data quality monitoring and privacy to be able to control, access across users. A BI or a visualization tool ultimately provides insights, to businesses, to folk who want to monitor metrics, and finally understand, a funnel down version of the data. This is what we generally refer to more or less as the data platform. And in our further discussion for build versus buy, this is how we're going to situate our conversation. All right, so now that we're all on the same page with what the data platform is and where we might need to build and buy, Let's take a look at some key considerations that we should keep in mind when making those decisions. I personally use these 5 key considerations on a very regular basis, very routinely at Lyra Health to determine whether I should build or buy. And I do this not just for the data platform, but I also do it for the ML sides, other infrastructure that we're responsible for. So the first one is cost and resources, complexity and interoperability, expertise and recruiting, time to value, and competitive advantage. So let's take a deep dive into each of these considerations and how you can answer this question of build versus buy. So diving into cost and resources, right? What are some questions that you should ask yourself? What's your budget for this component of your data stack? Will it cost more to hire and train data engineers to build this part of your stack or leverage a managed tool out of the box? What opportunities would you lose out on by dedicating resources to build this new tool? And what's the maintenance cost? Because you may spend a budget in building or buying a solution, but what are the recurring costs over time to support that tool? So while these are very, very basic questions, a lot of leaders and teams fail to ask and answer these questions diligently. So to give you some anecdotes and examples, for a large company like Uber, where we were operating at a massive scale, buying cloud solutions can be considerably more expensive than standing up open source ones. In some cases, open source solutions don't even address the problem at scale. And that's where Apache Hudi was born, out of limitations when we were running into problems processing hundreds of petabytes of data. In that situation, benefits of building in-house solution outweighed all the costs of any other. We'd reached a scale where it was really advantageous for us to spend the engineering resources to build something. However, at a startup like Lyra Health, we have to be more thoughtful of what we build. Hyper-growth startups have constantly evolving scale requirements and priorities. And so at Lyra Health, we're focused on building industry-leading platform mental health solutions. So it makes sense for us to buy out-of-the-box lakehouse solutions for our storage and compute stack, for example, and also consider managed ones. Overall, we found a cost-effective place for our team by utilizing a mix of both managed and open-source solutions. Another example I can give you is about data monitoring and observability. At Lyra, we evaluated building our own data observability framework, using tools such as Airflow, Slack alerts, etc. While this looked quite straightforward initially, when we dug into it and what it takes to build it, and really assign some person hours to the problem, we realized that there's more than what meets the eye. We need work on onboarding new data sets. We need probably some kind of UI if we want our partner teams to use this in a more self-service way. And then who's going to maintain this mini platform and add new feature requests? And at this point, we evaluated some data monitoring tools out there, and after deliberation, ended up picking one that meets our use cases and is also cost-effective. The next consideration I'd like to talk to you about is complexity and interoperability. Some things to think about here are, how is the ease of adoption? How will you evolve your homegrown solution over time as other tech evolves? Now, how will you make your current systems work together with whatever system you're introducing? These are questions that can help you understand whether the system that you're choosing to buy or build fits into the complexity of your data stack. So an example I can cite here is of data ingestion. If you're scaling a team with a relatively simple ingestion strategy, relying primarily on common data sources like Salesforce or MySQL or other OLTP sources, a solution like Fivetran or Fivetran's connectors will make a lot of sense for you. As many of you already know, Fivetran is a managed SaaS solution that provides this, that provides these kinds of integrations. That means less engineering time spent coding and maintaining pipelines, and less complexity down the road as you begin to invest in other layers of your data stack. Having said all of that, there are two major caveats. If you require custom ingestion for sources or latency guarantees that are specialized for a managed solution, or you have special requirements like sensitivity of data that you don't want to have leave your network, or you need to connect with sources and connectors that aren't supported by vendors such as Fivetran, the solution likely won't be sufficient for your needs. And due to the disparate moving technologies in ingestion, you may need a combination of things such as Fivetran, Kafka, Spark, and finally landing the data into the lake or warehouse of your choice. But in many growing organizations, a combination of Fivetran and custom pipelines using Airflow usually does the trick, just like it does for us. So again, here, it's been a combination of what we can build and buy. And at Uber, we continuously ask these questions when picking an open source software. Without interoperability, we couldn't talk the same authentication mechanisms. And making the adoption of that technology by a team quite steep. So asking questions about complexity and interoperability is fundamental to understanding whether you want to build or buy. The next thing I want to talk to you about is expertise in recruiting. This is probably one of the most important aspects to understand and think about when evaluating a build versus buy decision. Questions that I would urge you to ask yourself. What's your team structure and capacity? Does your team have the expertise to build this component in-house? Will they be able to maintain it efficiently without sacrificing valuable time for other priority projects? What's the projected team growth for the company? These questions are crucial to understanding, where you as a team and a company are situated when making a decision of build versus buy. Data engineering is now quite a broadly used term. Data engineering expertise ranges from building data infrastructure to data modeling to sometimes supporting business intelligence for your organization. So while choosing to build your tooling in-house might make the most financial sense in the beginning, it may affect your ability to staff and retain top talent in the long term. Throughout my career in data, the way teams have responded to the question of build versus buy has varied pretty wildly from one organization to the next. And that's due in large parts to the skill sets of those teams. At Uber, we had the luxury to hire engineers across the stack, whether it's all the way down to network engineers or infrastructure engineers or platform folk or folks who help with modeling. And answering this question was quite different when I compared to a company like Lyra Health, where we use a lot of cloud solutions and focus on providing good products for our customers. The next one that I want to talk to you about is a time to value. How long will it take to build the tool you need versus when you buy it? In some cases, even if you buy a solution, there are a myriad of steps that you need to go through. If the products are HIPAA compliant, what does your security team say about a product? Whether they're able to do some kind of penetration testing to approve the product and to be bought. How will the data be shared across the network? What kind of data will you share across the network? And then how then you may want to evolve your DevOps team. So there are a bunch of things to think about, even when you want to buy a solution, and it's not always that buying is fast and building is takes longer. And then how long will it take to realize its value? Like even after you start using the solution, you deploy it, how long will it take to realize its value? Another important question to ask is, how important is time to your company's product rollout? In some places you may be okay to wait for a while, and in some places, the product rollout is crucial to the business. And in those situations, you may have to make different decisions. And finally, is it better to choose an out-of-the-box solution and realize the value of your data faster, or build a custom one to leverage your data in a different way? With custom solutions, you can maybe have them deployed in-house, which lets you use sensitive and non-sensitive data together. Whereas, out-of-the-box solutions, that may not be possible. And so the value of the data is realized differently. Or maybe it becomes complex for your users to realize the value of your data differently. And so this important question comes up when planning your roadmap, like what's the urgency of these products? Sometimes the company is moving really fast, and, as a result, unforeseen challenges come up. For example, imagine at a fast growing company, the needs for data modeling are increasing rapidly. There are new use cases, new product lines being launched, and all of these need more analyses, and there are data analysts and data scientists knocking on your door for such answers. Now, while there's a reasonable sized data engineering team, it's possible they're unable to keep up with the numerous data asks. Now, on the other hand, in the analytics teams comprising of data analysts want to help, but they're not very comfortable with using a solution like dbt, for example, to build and deploy custom data models and views needed by the business. So what do you do in this case? Maybe the data engineering team uses dbt core, which is an open source solution, but then that gives the team access to the dbt platform in a more code friendly way. And while it's a great tool for data engineering, there can be a steeper learning curve for personas such as data analysts. So in this situation, what if a managed solution could reduce the barrier to entry, simplify usage and enable teams? And in this situation, your time to value for something is faster, because now your team is able to service a larger portion of your customers, and rather than actually either building an in-house solution that solves and self-services this, use like a managed solution. And these are like the junctures that we as a team at Lyra find ourselves all the time. So the last one I want to talk to you about is competitive advantage. This is an interesting one. Does your organization's success rely fundamentally on what solutions you pick? Can this solution enable your organization to be a market differentiator? Is your organization data-driven to rely heavily on data analytics to provide insights to win against competitors? An example that I can cite here is, Uber's operations teams, needed a lot of real-time insights into what was happening in the cities when I was at Uber. Data scientists, engineers, operations, everybody wanted more reliable, more consistent data that was free from underlying ingestion problems at scale. And this is where Uber needed a world-class data platform that implemented innovative solutions to power critical business decisions in a real-time, hyper-competitive space. And so building something in-house that provided that competitive advantage was helpful. Similarly, behind the scenes at Lyra, clinical insights and machine learning powers the platform, making recommendations based on patient symptoms, severity, location, and combined with this data on effective treatments for specific needs, and makes the right providers available to folk. So in Lyra's case, machine learning is the heart of the product and the platform. So it makes sense for us to invest in building some solutions in-house, and that are custom and tailor-made, that provide a differentiating value to our clients. And just like in the case, like I mentioned at Uber, the throughput and scale necessitated building something in-house to provide a differentiating value. So it all depends on how your company, what stage is your company at, your organization at, and what's differentiating value, and whether data can provide that differentiating value. So it's important to evaluate where you are in an organization with this with this particular aspect. So yeah, before I summarize, hopefully all of these 5 considerations sort of gave you an insight of how it's possible to make a decision of build versus buy for different stack of your data stack in your data platform. These considerations have helped me at Lyra. They've helped me at Uber, and I continuously keep evolving how I answer these questions based on where we are. And that's what I wanted to summarize with. Each time your organization clears a new benchmark in scale, the build versus buy debate continues. What works on day 1 doesn't work on day 1,000. What works on day 1,000 will become a bottleneck when maybe you're at IPO. So it's important to keep asking, are we small and cost conscious? Are we scaling quickly and moving fast? Are we large and well-resourced? Where we find in our organization and our platform on this maturity curve will color the way we view the build versus buy debate. Like the work of a good data engineer, the toil of the build versus buy debate is never done. But no matter what layer of the stack we consider, if we understand the needs of our stakeholders and the 5 considerations we've tried to outline in this talk, we'll be ready with whatever complexity the build versus buy debate can throw at us. With that, that's all I had, folk. Thank you. I wanted to open it up for any questions.